So, whenever you guys are ready, could you talk me through what you've built?
Yeah. So this is a microwave imaging system that is used to image like an object using the microwave like microwaves signals in the frequency range of gigahertz, like from megahertz, like 500 megahertz to some 24 gigahertz also. So here we have two Vivaldi antennas. Those they are the wideband.
Here and here.
Yeah, here and here. So these Vivaldi antennas can operate for wideband frequency. So these Vivaldi antennas operating from 2.4 gigahertz to like around 10 to 11 gigahertz. But since this VNA can only work till 8.5 gigahertz, so we will be doing the measurement from 2.5 gigahertz to 8 gigahertz. So this is like the system works like that. So this antenna have this S11 characteristics. So that means like minus 10 dB here means that if 1 watt of power is being transmitted from a VNA, then 90% of the power is being transmitted from antenna to the environment, to the air, and 10% is reflected. So minus 10 dB is a reference point that is being like accepted worldwide. Like below that, it's like best antenna. Like you have the more like S11 means the antenna is very good, and that antenna can work in that frequency range. Above minus 10 dB, yeah, your antenna is not it's like radiating like power, good power. It's
Sure.
reflecting.
It's
power.
reflecting a lot of
Yeah,
the power you send to it.
So
Okay.
these two antenna. So in this, so this is an object. So what like this system do? This system is trying to like measure the S21. S21 is like the power transmitted from here and received by this antenna,
Okay.
the receiver antenna. And then depending on the object, like depending the permitted of the object, there will be a loss in the power. So the loss will be will be showed like here using S21 and S12. Since this is a reciprocal system, like the antenna, two antennas are same, so we can like the S21 and S12 will be same.
Okay.
So this is 0 degree. So to image, like we will first image a slice of this object, and then we'll shift, like we'll change the height of, and then we will take a slice of that. So this is this is how we like image a 3D object.
Okay.
But to image a one slice, we will take projections from complete like 360 degree. With the step of you can take 10 degree, 20 degree. The more like less step, like 5 degree, the image quality will be more good. If you take 20, the time will be less. The time, like you can do the measurement in less time, but the image quality will not be good.
Okay.
So yeah. So now like we can start like our so we have two things here: the manual control and the automatic control. What manual control is? Yeah, you start the manual one?
Yeah. So for the user interface, we have manual control and auto control. First, we go through the manual control, and we have the rotation of the platform and lift of the platform. So first, we'll try with rotation. So since we are using a stepper motor with a 1.8 degrees minimum, so we are using that as multiplied to the user input as a degree. So we enter 5 here, we'll select degree selection to 9 degrees, and we press start to confirm it, it will rotate. And we use 0 to continue the movement. As you can see that.
Yeah, when it's rotating at each angle, you can see there is a variation in S21. A little variation is observed, but because
Yes.
because of the environment we are sitting here, so this will affect the like these parameters S21. If the environment like only one person is there, or like these things are not around, because these measurements are done in the anode chamber where there is like no like environment like problem. So but we can't do it, like we don't have an egg chamber, so we have to
So I just want to make sure I'm noticing the right things.
Yeah.
So you're rotating this at a prescribed number of degree
Yeah.
steps,
Yeah,
and
9
then
degrees.
as it rotates, what we're noticing is that this trace
Yeah,
here
yeah,
is
there will be-
changing.
yeah, we
Okay.
can,
And that's the information that'll go into building up a
yeah,
image.
yeah.
Okay. Okay.
Yeah, so we can also lift the platform. If we change to lift now, press 2, we'll lift up the platform.
There's a stepper motor turn in there. So to do a full image, you'll put it at a particular height,
Yeah.
start it at a particular orientation,
Yeah.
turn,
Turn.
get data, turn, get data,
Done.
and then you'll change the height and do the process again.
Yeah.
Okay.
Yeah.
Okay.
We can also like lift by 1 centimeter.
So the thing is, the microwave imaging can give up to 5mm resolution. So, but I think this system is like just a simple system.
Sure.
So it will. So we have just given 1 centimeter. So 1 centimeter, like it should be at least 1 centimeter up or down. So
Sure.
automatically we can adjust. So here we have a scale here. So you can like just lift up.
Okay,
Like
sure.
1 centimeter and like down centimeter, but we have like calculated at how many revolution it will take to go up and down, and according to that we have set here 1 centimeter and down 1 centimeter.
Okay.
You can like see if we press that 3, it will go up by 1 centimeter, and you can like check. using
Sure,
this
yeah,
also.
yeah. Okay. Wow.
So we also implement an auto solution for simplicity. So if we go to auto, first we select a rotation degree similar to the menu, like we select 9 degrees. In second, we select the rotation interval in seconds. So for faster, we select 1 seconds. Next, we manually lift the platform to, like, for example, its tallest level. So
What
manual.
what we're trying to use, like suppose we know the height of this object, so we'll start from the top,
Sure.
and then we'll do the rotation 360, and then automatically it will shift 1 centimeter.
Okay.
And then again the measurement will be done.
So it'll go through all these maneuvers automatically.
Yeah, automatically.
Okay.
Yeah.
After that, we continue. So we measure the height of the object. For example, like 2 centimeters. So we enter 2 and press down. We can automatically done the process, and we just need to capture the data.
Sure.
So you can see the little variation at higher frequencies.
Yes.
So you can see like here there's like a lot of power losses there, so that's why it was.
Sure. And now as it turns, we'll see less.
So it's reflecting off the surface? Is that
Yeah,
the
like-
surface?
Yeah, it reflected losing the energy because of the object. Yeah, no, it's going straight, but losing the energy because of the object.
Now it's doing another maneuver. Really, really cool. Seems like this could be useful.
Yeah.
Yeah, yeah. Awesome. Thank you, guys.